So now here we have another fading LED effect right there. Just one LED this time. You could also make it with the two LEDs. But in any case, we are using an op amp, an LM358 op amp right there. This one to the right is the square wave generator. That's the positive supply for the integrated circuit. The one on the left over here is a voltage follower. And there's a negative supply down there. We have the other op amp there, the LM358. When the output gets low, then the LED gets at its brightest right there. As the LED gets higher, the voltage equalizes across there, and therefore it fades off. The voltage that it is following is the capacitor voltage here. So this could not light the LED by itself, but it's charging and discharging. As its voltage goes up and down, it is transferred over to the plus input right there and being amplified. So now we're going to take a short look at the circuit that I put together to fade an LED. We got a couple op amps, but they're both on the same integrated circuit because I'm using the LM358. We have a square wave generator right here. So wherever you see the lines connected, they are connected. I use a little jump over the line if they are not connected. But in any case, we have the non-inverting input here. The voltage changes with the output, keeps going up and down. And then we have the inverting input. The output keeps charging and discharging the capacitor until it reaches the voltage that we set at the non-inverting input, which then flips the output and it has to go the other way. Pretty straightforward. The voltage of the capacitor is being looked at by the op amp that is a voltage follower. So whatever the capacitor voltage is, it's outputting that voltage and the LED lights up as the voltage goes down. It can provide more power than the capacitor.